-2 charge. Okay, now they may look the same in their products when we put them together, right? So we have a -2 charge. All right, so remember the crisscross method. All right, so we have and sodium. Notice this is sodium sulfate. The second equation right here, this gets 8 stars on top of it, is sodium sulfide, right? Sulfur is not a polyatomic ion, therefore it contains IDE. Sulfate is a polyatomic ion, right? So right here or right here, polyatomic ion, we have the ATE ending. Now ionic bonding quickly, all right, putting these together. We've gone over naming. How do we put them together? So we look at sodium and oxygen, okay, or magnesium and chlorine, or magnesium and oxygen. Okay, so we have 3 different atoms bonding to each other, or 3 different examples of different atoms bonding to each other. Let's take a look. And if you can't remember how to assign charges, just remember sodium, okay, sodium here is in the +1 group, or 1A. Oxygen here has a -2 ionic charge. Magnesium +2, chlorine -1. Alright, so then you can see for our bottom example, magnesium a +2 ionic charge, oxygen has a -2 ionic charge. So if you remember the crisscross method, all right, which is the only one I'm going to teach right here. If you found a different way to do it, awesome. But this is the only way I've taught in class, so therefore I'm going to continue it. We're going to take this 2, okay, and we are going to move it down and attach it to the sodium. Vice versa, we're going to take this cation charge, the 1, and we're going to attach that to oxygen. So we have 2 sodiums bound together with 1 oxygen. Now, I wrote the 1 in right here. A 1 is implied. Okay, so when we write Na2 or sodium oxide, okay, it is Na2O. If I see an oxygen, if I see a chlorine, if I see a fluorine, a sulfur, okay, attached to the end of a bond, and there's nothing behind it, there's no subscripts attached to it, I am assuming that it is a 1. Okay, and the same goes the exact same for an anion, and you'll see that in the next example. So go ahead and try and put magnesium chloride together. Okay, I'm assuming you've tried to ionically bond magnesium and chlorine. Well, what does it look like? Magnesium, well, that has a +2 charge. That's going down and attaching to the chlorine. Chlorine has a 1 charge. Remember, it has a 1 attaching to the magnesium. I don't need to write that in. So go ahead and snuggle that chlorine up right next to the magnesium. Write the 2 subscript. That's coming from right here. Okay, so that is what magnesium chloride looks like. Okay. Next example. We're dropping both our 2's down, so we have Mg2O2. Well, magnesium oxide, right? We have two subscripts that have a common number. That's 2. So let's reduce that. Lowest ratio possible, the lowest whole number ratio, right? The lowest whole number that these two have in common, well, is 2, right? 2 divided by 2 is 1. Therefore, right here, magnesium oxide is our final answer. Let's look at a few more examples. Magnesium hydroxide, sodium sulfate, and let's go with aluminum sulfate. Using your periodic tables, go ahead and try and assign each one of these a charge. Okay, now that you've done that, hydroxide, OH, is kind of tricky. It ends with IDE, but it is a polyatomic ion. You should be familiar with that when it comes to acid-base reactions. Magnesium, you should see, is a +2. Oxide, or hydroxide, excuse me, is a -1. So use your crisscross method. We can say that the bonding of magnesium hydroxide is Mg. Now we have 2 of a polyatomic ion. Remember, OH are bound together. Okay, so if we need multiple OH or hydroxides, we need to put parentheses in a subscript. Okay, I am saying that I have 2 hydroxide atoms to my 1, magnesium. That makes up magnesium hydroxide. If you don't put the parentheses, okay, so say you labeled this here and you put a 2 right there. That changes. Now you have magnesium and water bound together. That is not the same thing as magnesium hydroxide. That is why parentheses are so important. Okay, sulfate -2, aluminum +3. So now we have all of our charges assigned. Put them together. Sodium sulfate. And now we have aluminum. 2 of those, right? 2 drops down. And now we have 3 sulfates. So aluminum, parentheses, right? SO4 is sulfate, so keep that together, and we have 3 of those. Quickly, let's talk about covalent bonds. Okay. Now, there are a few differences in ionic and covalent bonds. Covalent bonds are between a metal and a nonmetal, or a cation and an anion. Covalent bonds are between 2 nonmetals, or 2 anions. Okay. Covalent bonds are sharing electrons, whereas in ionic bonds, there is a transfer of electrons from a cation to an anion. So then the cation no longer has its straggler electron, it has given it to an anion. Okay, covalent bonds, the electrons are, say, in, well, chlorine and oxygen. Okay, we're just going to go ahead and say that these two have started to bond together. There is going to be an electron cloud between both of these. Okay, and the electrons here are going to go back and forth between these elements, but it is going to spend most of its time in between both of the elements, or the atoms. Why? Because right here there's a strong pull for the electron to be, the shared electrons. Alright, now naming. Alright, you need to be able to distinguish an ionic from a covalent bond. Well, you see 2 nonmetals, it is a covalent bond. Alright, so the first rule of naming an ionic bond, okay, right up here, top left corner, the first element in the formula name is named first using the normal name of the element. So if we have oxygen, it is going to be oxygen. Okay. If we have fluorine, it is going to be fluorine. All right. Now, if we have here the second element, okay, so we have CO2. Yes, it's carbon dioxide. All right, I just gave you the name for it. Well, the second element name is named as if it were an anion. We've already determined that anions end with IDE. Okay, IDE. So there are no ions in these compounds, but we use IDE ending on the second element as if it were an anion. Don't get boggled down in that. All right. IDE is the ending. Okay. Greek prefixes, shown in this table below right here, are used for each element to indicate the number of the atoms of that element present in the compound. So notice, there's a 1 here and a 2 here. We need to go to rule number 4 first before we proceed. Okay. Greek prefixes, right, or the prefix mono, which is 1, is never used for naming the first element. Okay, so our book gives an example. There's a difference between these two elements. You can see there's 2 oxygens here as opposed to 1 up here. For both of these, they're going to start the exact same because there's 1 carbon. Okay, so it's carbon and carbon. But now we know there's 1 oxygen here. Well, down below we have 2 oxygen. Now we need to add the mono. Monoxide versus dioxide. Right? So you are just adding Greek prefixes to the anion name. Now, here's the difference. Say we have we have a gas. We have 2 carbon and 4 hydrogen. All right? Here's where we need to add a root to the first element. Well, we have 2 right there. We've got 2 right there, so we're going to name that di. Keep the original element's name. So dicarbon. We have 4 hydrogen, so we look up here, we go 4, okay, tetra hydride, excuse me. All right, dicarbon tetrahydride. All right, so for the last little bit, I want you to be able to write these, predict the products, and I would also like you to be able to balance these. So let's take a look. When we're writing, okay, we see that for the first equation we have iron. Right, we're writing for the reactant side. Reactant side is everything on the left side of the arrow, and then products is going to be on the right side of the arrow. Remember that this sign means reacts with. The arrow is yields or produces. And the plus sign on the product side of the equation means and. Okay. Now that you know all that, let's go ahead and try and write out predicting our equation, okay, predicting what we know about iron and copper, which are transition metals on the periodic table, which usually or oftentimes means